Hello everyone, welcome to lecture 25. So today we will start the Glacial Lake Outburst Flood. This is the part 1 of lecture 25 and this belongs to module 7. So in this lecture we will particularly see what is glaciers, what is glacial lakes, how they form, what are the different types of glacial lakes and what we mean by GLOF, Glacial Lake Outburst Floods. Right. So, let us start this from the beginning, what we mean by cryosphere, so that in case if you have missed the previous lecture, you will be able to follow all the contents of this lecture. So, the cryosphere encompasses all forms of frozen water on earth including snow, glaciers, ice sheets, icebergs and permafrost. Right. A glacier is a large perennial ice and snow that is constantly moving under the influence of its own weight and gravity, right. So, unless until a glacier mass or the glacier ice does not move, we do not call it glacier, right. So, we will call it ice sheet or ice or snow, but we never call them glaciers unless until they do not start their movement. So, the Indian Himalayas particularly contains the world's largest number of glaciers and snow outside the polar region and is aptly called the third pole of the world. So, this is very important. The Indian Himalayan regions are very important in terms of cryospheric studies. It consists of 3 major river systems, Indus, Ganga and Brahmaputra, stretching over 5 countries, India, China, Nepal, Pakistan and Bhutan. We all are having the parts of this fluvial system which is originated from the Indian Himalayas. This is the Hindu Kush Himalayas, right. So, here you can see we have Karakoram, Western Himalayas, Central Himalayas, Eastern Himalaya, and the Hindu Kush Himalayan region has about 8,000 glacial lakes, and the North Indian states Uttarakhand, Himachal, Jammu and Kashmir have 200 lakes. So, you can see how important it is to study the glacial lake, particularly in the Indian Himalayan region. So, let us understand the basic features of the glacier. So, the accumulation zone, the area above the equilibrium where total snow accumulation exceeds ablation is known as the accumulation zone, right, where the snowfall happens and it accumulates and slowly it gets thicker and denser, right, and then it takes the form of ice and subsequently it forms a glacier. The equilibrium line is the boundary that divides the glacier surface accumulation and ablation zone. So, here you can see this red line. So, you can easily say that here in this particular area the melting is happening and here you have the snowfall, right. This is the accumulation zone. So, definitely this will be the higher altitude, this will be the lower altitude. The ablation zone basically in this region, right, the zone below the equilibrium line where total ablation melting is higher than the accumulation. So, it is not necessary, but the melting happens in this region only and we call it ablation zone. And the snout, this is also very important, the snout is the mouth of the glacier. So, if you see this is a glacier boundary and here basically it is ending, right. So, this is the lower altitude and here it starts melting and it is feeding this particular lake, right. So, in this condition we have the snout here, right. So, the lowest point of a glacier known as its terminus or toe where the ice mass ends, right. So, here this is the location. So, now let us try to understand the glacial lake particularly. So, here you can see this is one of our field photograph, and here you can see, if this is clear to you, this is a glacier flowing from top, right, it is coming from this region. Now, this definitely this is the snout of the glacier, and it is actually melting and slowly it is feeding this particular lake, and there is one more lake in this side, right. So, this is how they melt, and the melt water gets accumulated in the snout of the glacier where there is some depression, right, and because of the depression the water will get accumulated and slowly they will take the form of a lake if it is continuous, right. So, this is another diagram to just to explain, if this is the glacier and it is the snout of the glacier, slowly it is melting and it is getting accumulated here, right, and then subsequently it takes years to develop this kind of a lake, right. So, the glacier retreat plays a very important role. So, the retreat is a process where the snout of a glacier moves back up, right. So, it will move up because of the melting the valley due to net ice loss, indicating more ablation than the accumulation, particularly in this region, and then subsequently we will have the development of a glacial lake. So, here you can see some of the real glacial lakes which are located, right. So, the details are given here. So, this image I am using here to explain how these lakes are formed, what is the source of the water. So, basically here it is the melt water, and this kind of depression that helps to develop the glacial lakes, and earlier this was the snout of the glacier, but because of the retreat the snout has gone up and now this area is available for lake formation, right, and these are the moraines. We will discuss this in detail, the moraine part. So, let us try to understand the glacier lake. A glacial lake is a body of water which origins from glacier activity. They are formed when a glacier erodes the land and then melts, filling the depression created by the glaciers. The glaciers lakes are often dammed by moraine or ice. So, as I said, this was the earlier snout of the glacier, but because of the retreat this snout has reached to this level and this area is available for glacial lake formation, right. In the Indian Himalayan region, most glacial lakes are formed due to retreating glaciers as a result of climate change. Over 5,000 glacial lakes have been identified in the Indian Himalayan region, primarily in Sikkim, Himachal Pradesh, Uttarakhand and Jammu and Kashmir. The majority are located in the upper reaches of river basin such as the Indus, Ganga and Brahmaputra. This is from the ICI MOD report. So, here you can see the accumulation zone which is highlighted. So, these areas are receiving the solid precipitation. So, here actually the accumulation happens and these are the ridges, right. So, here you can see this kind of feature. So, these are the ridges, and here since we have this snout here and here basically the melting happens. So, this water will start reaching to this particular depression. So, this is called ablation zone and these are the glacial lakes. I hope this is clear. So, this is another image. So, these images have been generated using AI just to explain the features, right. So, here this is the glacier which is flowing down and this is the snout of the glacier, and here you have the formation of glacial lakes. The formation of glacial lake can be understood in this particular slide. The accumulation of glacier melt water unable to flow naturally due to barriers like ice dams, bedrock or moraines results in the creation of glacial lakes. This is what we have seen in the previous slide. So, we have different types of lake: moraine dammed lake, where we have the moraines, then we have ice dammed lake, then we have glacial erosion lakes. Because of the erosion, depression generates, and because of that depression which is available to accumulate the water, we have the new lake formation which is called glacial erosion lakes. And then we have also the other glacial lakes fed by direct melting of glaciers within the glaciated valleys, right. So, here you can see the failure of moraine dam can be understood. So, here the first one is overtopping and erosion, piping due to seepage, and dam integrity. So, these are the different causes of the moraine dam failure. And here in this particular image you can understand how the glacial lakes are formed. So, here you can see the beautifully they are explaining the retreating results in the formation of glacial lakes at several positions, right. So, these are called marginal lake, right, and here you have the supraglacier, here you have another lake which is also connected to a river channel, and here also we have a glacial lake, and these are the fluvial channel which is connected to these glacial lakes. In lake formation and the lake breaching, we need to understand the breach in season. So, when the flowing water erodes a moraines channel, a positive feedback loop is created. This is when a breach in season occur. So, here you can see this is the glacier which is feeding this particular lake, right, and there is a moraine breach here, and slowly the water will start flowing in the direction. Here, because of the moraine breach, the water will flow downstream. The increased water flow accelerates erosion, thereby causing failure of the dam. The process can then lead to rapid moraine dam lake drainage and potential glacial lake outburst flood. This is the concept of glacial lake breaching, right. We will have more details on the breaching, and here you can see the Bishop Glacier Lake of Canada, how it is increasing in size over the year, right. So, here you see how it is increasing and what is happening to the snow or the glacier present over this particular area. Similarly, you can see the example from South Lonag Glacial Lake. This image is from 1967 and this is the size of the lake. Now, here you can see this is from 2022, and here we have also marked the earlier traces, the boundary of the glacial lake, how it has increased over the year. So, we have to be very careful and we have to continuously monitoring these glacial lakes which are susceptible to GLOF. So, here this particular video will try to explain how it is changing with time. So, you just carefully see the video here. In 2023, this particular lake was failed and we had a glacial lake outburst flood, and the reason was calving. So, there was one moraine and that calved and it fell into this particular lake in the South Lonag. Because of that, overtopping happened and this particularly breached the moraine which was available here, right, and then this caused the glacial lake outburst. And here you can see the importance of the glacial lake, why we need to study them. So, these are the fresh water resources for us, and these are a very good climate change indicator, because if there is a new formation of the glacial lake, then retreating is happening. If some of the lakes are vanished, that means more glaciation is happening or the accumulation is happening. Tourism and livelihood, that is also there, because for the local people this helps to attract people and to improve their livelihood. ecological importance, naturally the ecology of that particular area will be maintained, and they have also the potential of hydropower generation. And then the most important thing, we need to be very careful and we need to monitor these glacial lake for any potential hazard, right. The formation of the glacial lake can be understood here. The glacial lakes are typically formed by the accumulation of meltwater from glaciers. The lake is held back by moraine, the accumulation of the glacial debris or ice dams. This image shows a high altitude snow covered mountainous region. Several glacial lakes are located near the end or along the course of glaciers. So, these are highlighted with these circles, right. The image emphasizes how melting glacier contribute to the development of these lakes in an ever changing icy environment, right. So, here you can see slowly they are getting generated and slowly they are increasing their size. So, some of them will be having the potential to glow. So, we have to keep on monitoring this, what is the status of the glacier in that particular area, how the mass is changing, the mass balance, and how the glacial lakes are increasing their size. The formation of glacial lake has these major component. So, the first one is the melting process. As a vertical thinning of the glacier happens, then we have global warming. Rising temperature accelerates the rate of glacier melting. Then glacier retreat. Accelerated glacier retreat has led to the significant enlargement of glacial lakes. As a result, horizontal expansion of the lake increases across the Himalayas. On average, glacier retreat in the Himalayan region is 10 to 14 meter per year, right. So, this is a very generic statement. Now, let us understand the various triggers that can initiate a glow. So, the contact glacier calving, so that we have seen in the previous few slides. Ice fall from hanging glaciers, right. So, this Rishikesh valley was one of the example. Then rock, ice or snow avalanches, dam settlement and or piping, ice cored moraine degradation, rapid input of water from the supra or subglacier, and any other earthquake, or earthquake can also trigger this glow event. So, here you can see this particular conceptual diagram beautifully explains the process. So, what is happening here? This is the melting zone. So, it is melting and slowly it is feeding this particular glacial lake, right, and then it is coming to the fluvial channel. Now, here if there is a breach at this particular point, what will happen? The glow can be seen here, right. So, here this is the zone where we can have the embankment breach, right, and here you can see this is linked to a real image. So, here this is the snout of the glacier and here it is melting and this lake is fed by this melt water, and here if something happens to this particular embankment, then in the downstream you can see the glow event. The Himalaya is called the third pole due to its vast snow and glacier coverage, and it is extremely vulnerable to global climate change. Rising temperature of the earth accelerated the retreat and thinning of glacier, leading to the formation of new glacial lake and the expansion of existing one that we have seen in the Sikkim Himalayas, right. So, we have one paper that is given in the link. There we have seen many of the new lakes are formed and slowly they are increasing the size. Glacial lake formed by the melting of glaciers are important source of fresh water for Himalayan rivers, but also pose a serious hazard in the form of glacial lake outburst flood. Analysis of satellite data from 1984 to 2023 reveals that 676 glacial lake out of 2431, which is more than 10 hectares, have significantly expanded. Among them 130 are in India within the Indus, 7 in Ganga and 58 in Brahmaputra, right. So, here you can see the glacial lakes in Himalayas. So, number is 28,000. So, it is including all the sizes, and here it is also classified in different types. Similarly, in Indus, what are the different types of lake we have, then what is their distribution. Then we have glacial lakes in Ganga. So, here you can see 4707 and different types of lakes are here. Then glacial lakes in Brahmaputra, here the number is too high, 18,001, and different types are listed. So, if you want to know more and explore this information, you can go to this Bhuvan website and you can see the details. So, let us try to understand what are the different types of glacial lakes we have. So, glacial lakes are divided into 4 major types, right. So, we have referred to the NRSC inventory for this. First one is the moraine dammed lake, then we have ice dammed lake, then glacial erosion lakes and the other glacial lakes. So, here some of the examples so that you will be able to understand what we mean by that. So, glacial erosion lakes are like this. It is because of the erosion activity of the glaciers, right. This depression has formed and this acts as the dome where the water can accumulate. And this is the ice dammed lake where ice is acting as a moraine, right. Then we have a moraine dammed lake. Here the moraines are actually making these embankments, right. Let us try to understand the moraine dammed lake. When glaciers melt, the water in these glacial lakes accumulates behind loose naturally formed glacial moraine dams made of ice, sand, pebbles and ice residues, right. So, here this is the glaciers, right. So, it is flowing in the downstream, right, and this is the zone and this is, let us say, this is the snout of the glacier, and here some depression is formed and here the accumulation happened and we have the moraine dammed lake, right. They are unstable and potentially leading to glacial lake outburst flood because these are the loose grains, right, and slowly over the time they get compacted and they have a very good strength. If the moraine dam is impermeable, the lake continues to fill until it reaches a balance through seepage or overflow. Outburst can be triggered by factors such as heavy inflow, if you have more melting, flood surges because of maybe the calving, internal seepage because of the seepage in these moraines, high hydraulic pressure because of the amount of water, or the thawing of permafrost caused by rising temperature, because ice are also present here. If there is a change in the temperature too much, what will happen? This will melt and then the strength of this moraine will be lost. Now, we have the ice dammed lake. Ice dammed lakes commonly form in area where a tributary valley is obstructed by a main glacier, right. So, here you can see this is the tributary glacier and this is the main glacier. They may also develop when a glacier form a side valley advances into and block the main valley. Other typical location includes gap between a glacier lateral margin and the adjacent ice free valley wall. Ice dammed lake can also emerge at a junction where two glaciers converge. Now, we have subglacial lakes. So, this is basically the location. So, you can easily understand it is subglacial, that means it is beneath the glacier. So, subglacial lakes form beneath glacier ice where there is no gradient for fluid potential. Water is routed from the glacier surface in glacially to the base where it collects to form these lakes. Although subglacial lakes cannot be directly identified using satellite imagery, their presence is often inferred from the occurrence of geochroplasts. Now we have supraglacial lake. Supraglacial lakes form on the surface of the glacier. So here you can see this is a glacier which is flowing, right, and here these lakes are on top of the glaciers, right. So the base of these glaciers will be the ice or the glacier ice, right. Meltwater accumulates in depression or hollows of these ice surfaces, right. So you can see this image. Supraglacial lake typically formed due to melting processes and are commonly found in the lower ablation zone of glacier covered by debris. This is an example of supraglacial lake on the surface of the glacier in Bhutan, right. So these lakes are from the Bhutan. So here this is another example from this particular paper, and you can see how these lakes are formed on top of glaciers, right. So these are called supraglacial lakes. Glacial lake cascade. So this is from Changbakshya Glof. The new glacial lakes are formed at higher elevation above existing lakes. It will increase the risk of cascade outburst event. So this is the aerial view depicting the position of 3 interconnected glacial lake. So here this is one, this is second one, and this is the third one. Now you see the connection. So these 3 are connected, right. So if there is some breach of one of the glacial lake which is located at the higher altitude, then the lower altitude lakes will have more potential to glow, right. In this scenario, even a small outflow from a upper lake can potentially trigger a major release from the lower lake, right. So we have the example from Changbakshya. So a cascading flood event occurred in the eastern Himalaya in 2001, initiated by an ice avalanche into Chongabakshya, which triggers the initial event. This outburst subsequently propagated downstream, impacting the low-lying lakes. In this particular slide, we will try to understand the glacial erosion lakes. These lakes are formed by glacier erosion, where the glacier carves out depression and fills them with water. Cirque Lake formed in the rounded depression of glaciers, and through valley lakes formed in the border U-shaped valley carved by glaciers are examples of erosion based lakes. The other glacial lakes that we have discussed earlier also, glacial lake formed by glacier erosion, which are difficult to identify by morphological feature and do not belong to the other type described in the following, can be classified as another glacial erosion lake. These other lakes can exist beneath, within, or on top of the glacier. So it can be subglacier, inglacier, or supraglacier, right. So the glacial type and their identification keys. A 2-character coding system is used to classify glacial lakes, where the first character is an uppercase letter indicating the main type of the lake, and the second character is the lower letter enclosed in parenthesis that denotes the specific subtype. For instance, the symbol ME, so you see the ME identifies an end moraine dammed lake, right. A comprehensive list of glacial lakes type is presented in the next slide. So there you will be able to understand how we are using this identification keys. So here we have ME, MI, MIG, and the details are given in this table. So I hope this will help you to read, or in your work you can also name the glacial lakes. The types of moraine dammed lakes. So we have end moraine dammed lake, lateral moraine dammed lake. The lake, depending upon the position and morphology of the dammed condition, The moraine material may be ice cold or ice free. Before the ice body of the glacier completely melts away, glacier ice exists in the moraine and beneath the lake bottom. The ice bodies stored in the moraine and beneath the lakes are sometimes called dead ice or fossil ice. As glacier ice continues to melt, the lake becomes deeper and wider. Finally, when ice contains in the moraines and beneath the lake completely melts away because of the high temperature, the container of the lake water consists of only the bedrock and the moraines. So, here you can see the example of moraine. Here this is the glacier, right, this is the snout of the glacier at present day, right, but you can see this particular ridge. So, it shows the earlier the snout was maybe here, right. Because of the retreating of this glacier, this feature is still present and this is what we have the lateral moraine, right. This is we call lateral moraine and this is the middle moraine in between. I hope this is clear. Here we have another example to explain the lateral moraine and how they form. So, here you see how these glaciers are connected and flowing downward, right, and here in between you have moraines. So, I will just mark the moraine only. So, you see this is the boundary of the glaciers. So, these are basically the moraines, right. Here also we have moraines. So, in this particular image you can see this is the ridge, right. So, this is basically your moraine. So, with this I will end the part 1 of this lecture. We will continue this discussion in the next part. Thank you very much.